Very good morning to everyone. In this lecture, EC 8351 Electronic Circuit 1. In previous session, we are discussed the introduction of the BJT amplifier. Now today we are going to discuss the BJT differential amplifier configurations. Here we see the BJT differential amplifier schematic configurations model. Here the transistor differential amplifier basically uses the emitter bias circuits which are identical in characteristics. The output is taken between the two collectors. None of them it is grounded, then it is called a balanced output, and a double end output or floating output are there. Now what are the operating mode, that is a mode of operation in differential amplifier. There is a two different mode, that is a differential mode operation and a common mode operation. The differential mode operation, the two inputs, the two input signal are the same magnitude but opposite polarity. It is a 180-degree out of phase. And then the common mode, the two input signal are equal in magnitude and same phases that are used in the input side. This is a difference between the differential mode and also the common mode signals. Now let us, the first one is a differential mode. We assume the sine wave on base of Q1 is positive going signal, while on the base of Q2 that is a negative going on the signal. That is a one input is a positive and second another input is a negative. So here we see the circuit of we are applying the source, that is a central tap transformer. You are using the source voltage, that is a reference voltage, and also the initial threshold voltage VCC is applying there the collector and collector resistance of two different transistors, that is a Q1 and Q2. So here an amplified, the negative voltage going small will appear at the collector of Q1, and an amplified, the positive going signal will appear at the collector of the Q2. Due to the positive voltage going signal of base of Q1, the current increases in the emitter resistance, and hence positive voltage going wave developed across the RE. So due to the negative voltage going signal of the base of Q2, the negative voltage going wave is developed across the emitter resistance because of the emitter follower action of the Q2. Now the signal voltage across RE due to the effort of Q1 and Q2 are equal in magnitude and 180 degree out of phase. Due to matches the transistor, hence the two signals cancel each other, and there is no signal across the emitter resistance. So the no AC signal follow the through it. So the output voltage is equivalent to the two different input, that is output is differentiate voltage into input signal. So what is the common mode? It is a function of the differential mode configurations. What is the common mode signals? In common mode operation, the two input signal are equal in magnitude and the same phases are used. So the phase signal developed in phase signal voltage across the emitter resistance. Here the emitter resistance carry a signal current and provide a negative feedback. This is a the negative voltage of feedback decreases the common mode gain. In this signal, voltage of equal magnitude will appear across two collector of Q1 and Q2. So it is ideally should be a zero. It is a negligible in the zero voltage. So the configurations, what are the different configurations? So what are the different configurations in differential amplifier? The differential amplifier in the difference amplifier stage in the operation amplifier can be used in four configurations. The first one is a dual input balanced output differential amplifier. The second one is a dual input unbalanced output. Third one is a single input balanced output. Fourth one single input unbalanced output. So out of these four configurations, the dual input balanced output is base of differential amplifier configurations. So we have to see the dual input and balanced output differential amplifier. So here the two differential amplifier, that is a two differential Q1 and Q2 transistor in the dual input, that is a dual input, and a balanced output are there, that is a V naught. It is a two input is a positive and negative. It can be coefficient to the produce the output in the balanced and stable output of V naught. So in this session we are discussing the differential amplifier and what are the characteristics, what are the category of two differential amplifier configurations, and what are the output voltage of balanced and imbalanced output of differential amplifier stages. Thank you for watching this video.